right, so now what we're looking at is we're looking at scenario 4, and this is something for our two-sample t-test. So let's look at the scenario. Suppose that you wanted to determine if a drug improves students' abilities to concentrate and study. A study conducted by a pharmaceutical company recruited 125 students with average IQs to participate in a randomized clinical trial. The drug company split the recruits into two groups. Group 1, the placebo group, was given a sugar pill. The second group, Group 2, the treatment group, was given the drug. They were then asked to complete a very difficult task, and the amount of time they took before they quit was calculated. They claim that the treatment group will be able to spend longer on the class than the placebo group. You will test the claim with a significance of 0.01. So the first thing that I want to ask myself is, what's the variable that's being collected? What is the variable? Okay? And the variable in question is going to be the amount of time they took before they quit. Okay, so it's an amount of time, so consequently that's a quantitative variable. In addition to that, I'm going to notice that I've got the group, they're split into two groups. One's the placebo group, and the other one's the treatment group. So that's a quantitative variable from two different populations. So consequently, since I have a quantitative variable for two different populations, the test I should be running is going to be my two-sample t-test. If you remember, because they're from two different populations, and because the groups in each sample are actually not connected in any way, these are what we call independent samples. All right, so hence that's why we're going to use the two-sample t-test instead of something like the matched pairs. All right, now for the two-sample t-test, what we want to get is we are measuring a quantitative variable, the mean in this case, mean time, okay, from two different populations, two different unconnected or independent populations. Okay, great. So there we go. Now, what about the null alternative hypothesis for this test? Well, it's a two-sample t-test, and so since it's the two-sample t-test, my h0 is going to be mu1 equals mu2. That is, the two means are exactly the same. My ha, okay, is going to be mu1 is less than mu2. How do I know that? Well, group 1 is my placebo group, and group 2 is my treatment group. And we said that the treatment group would be able to focus longer, would spend more time before they quit. Okay, so consequently, mu2 should be larger. The second mean should be larger. All right, if I write this as a sentence, h0 is going to be the mean focus time for group 1 for the placebo group is the same as the mean focus time for the treatment group. And then, if we want to look at my alternative, the mean focus time for the treatment group is, the placebo group is less than the mean focus time for the treatment group. Okay? Cool. So what we're asking is, if we reject the null hypothesis, we're actually saying that one group, in this case, the treatment group, spent longer on the task than the placebo group. So when we actually look at what's going to be the result of our test, that's what we're asking, right? Did they spend longer? And if they spent longer, that might tell me that the drug actually worked. It increased focus time. Okay? Now, The following information was collected from two groups. What we have here is we have some summary information. The placebo group had an x bar 1, that's the mean, of 24 minutes, S1 standard deviation of 8 minutes, and N1 of 45 minutes. And treatment group 2 had a sample mean of 32 minutes, S2, its standard deviation of 7.2 minutes, and N2, its sample size of 80. Okay? So one other indication that this isn't going to be matched pairs is that we actually have two different sized samples. If they were actually matched, they'd have to be the same size in order for them to be actually matched. Okay? So, amongst other things, that also is an indicator for us that we're going to do a two-sample means t-test. Okay? Now, let's take a look at these questions of what is the test statistic, what is the p-value, and then ask ourselves, should we reject or fail to reject the null hypothesis? So what I'm going to do is, because I already know, because I figured out earlier on that I'm doing a two-sample t-test, I could just put my information into the computer and actually have it give me both my test statistic and my p-value. If you feel more comfortable with equations, you can do that, but you don't have to. All right? In fact, I never do anymore. Computers are good for certain things, and this happens to be one of them. So I've got stat. I'm going to go t-stats, two sample, and in this case, it's going to be summary. So that's stat, t-stats, two samples, and it'll be with a summary. Okay? Now, we'll look back here. I got 24, 8, and 45. So those are my values. So I'm going to put those into StatCrunch. 24, 8, and 45. Okay? And for my other group, I've got 32, 7.2, and 80. 32, 7.2, and 80. Then I want to actually state my null and my alternative hypothesis. I'm actually making a comparison. Mu1 minus mu2 equals 0 because I stated that they're the same. And then mu1 minus mu2 is now going to be less than 0 because mu2 should be greater than mu1. Okay, so mu1 is less than mu2 is the same as mu1 minus mu2 is less than 0. And now I'm just going to go on and compute. Decimal point. And a comma instead of a decimal point. So I go in and compute. Sweet! So here's my results. Let's go in. Let's take these out. Okay, there's my results. And so what I get is a t-statistic. My t-stat is t equal to negative 5.560. Okay? Just as a side note, that's really, really big. That's 5 standard deviations away from the mean. That's like impossible if they were actually from the same distribution, right? Already tells me I'm going to reject the null. But then I have p, my p-value, there this is. There's my p-value. It's less than 0.0001. So p is less than 0.0001. Okay? There's my p-value. Okay? And then when I ask, should I reject or fail to reject the null hypothesis, this is going to be reject. Well, let's see if we gave an alpha. Oh, there's my significance of 0.01. So alpha is 0.01 up here. But p is less than 0.001. So reject the null hypothesis since p is less than 0.0001 and alpha equals 0.01. So p is less than alpha, right? That's our requirement to reject the null. If p is not less than alpha, we're going to fail to reject. Okay? Now write complete sentences, the conclusion of the test. Well, so I can either go back. What I'm going to do is I'm going to look up here, and I've got my null hypothesis. And that's the thing I'm rejecting. I'm rejecting the fact that the mean focus time for the placebo group is the same as the mean focus time for the treatment group. That's being rejected, right? That's not right. What is the thing that I have support for? Well, I have enough evidence to support that the mean focus time for the placebo group is less than the mean focus time for the treatment group. And so that's what I'm going to say, right? I'm going to support my alternative. So I'm just going to say the mean focus time. Oh, there is sufficient evidence there is sufficient evidence to support the claim that, and then we're going to actually state the claim, that the mean focus time for the placebo group is less than the mean focus time for the treatment group. And that's it. Well, that's a great realization, right? Okay, we've got sufficient evidence to support the claim that the mean focus time for the placebo group is less than the mean focus time for the treatment group. Okay, so what does that mean? That means that the treatment group actually performed better on the task because they were supposed to focus for longer. And that means that the drug was actually effective in improving focus time, right? So suppose that you wanted to improve your ability to focus in order to improve your grades on standardized test scores. According to the test that you performed, is there statistical evidence that you should take the drug? The answer is yes. Because the evidence shows the group that took the drug, performed better on the focus group, on the focus time task. That's it. There it is. Now, it's a process, but the process is a logical process that if you follow, you can actually come to this kind of conclusion and know that you have evidence for that kind of conclusion. That's the whole point of doing this. The whole point of doing this is to see whether or not we have actual evidence to support a particular conclusion. So we start out up here and we say, hey, you know what? Here's my question. My question is, does this treatment group that's been given the drug do better, okay, on tests in focusing than those who were not given the drug, okay? And so in order to do that, I find out, okay, I've got a quantitative variable, time, and that's going to, in fact, be between two different populations, so it's a two-sample t-test. Then I come up with a null hypothesis. My null hypothesis is that the two groups, they do exactly the same. There's no difference in them. And then I have an alternative, the one that I actually believe, is that the placebo group is going to focus for less time than the treatment group, right? Then all my other work is to figure out if I'm going to reject the idea that they have the same focus time. If I go out and reject it, then I'm going to be supporting the alternative, which is to say, basically, that the treatment group did better on the tasks, and so hence my drug improved focus time, okay? So like that's the idea. Do I know really about my drug? Not really, but it's a pretty safe conclusion, or well, it's an okay conclusion for me to say that my treatment group did do better than my placebo group. That's the evidence that I got. Okay, they focus for longer. They're statistically true. And then the conclusion that I can draw from that is in fact that the drug in fact worked. Okay? That concludes our test for the two-sample t-test.